So, hello everyone. Are you enjoying NG Poland conference so far? Yeah, I do as well. So, my name is Tomasz Ducin. I do trainings, I speak at conferences a little bit, and I work for a Cybercom Poland company, where I'm responsible for designing architecture and implementing, let's say, enterprise-scale interfaces. For the last couple of years, I've been working for financial sector. The recent project I've been working for almost 2 years is, as you may guess from the talk title, is based on Angular 1, and it's quite big, I would say. It's a banking interface for the end customers. It's been deployed to over 120 banks in Denmark, Sweden, Norway, and Faroe Islands. The challenging thing in this project is that it's pretty customized. Like, each of these banks require different behavior, it requires different look and feel. Additionally, if you want to access any kind of data, then it gets pretty complex because there are lots of different core backend services. So it's pretty, let's say, confusing to get things up and working there. So to get just one module working on Angular, let's say, platform, it took us over 1 year to reach production. So you can imagine that it's not an easy task. Basically, the experience I gained throughout this project is what I want to share with you during this talk. So when you join an, let's say, enterprise company, you will hear the word architecture a lot. So it's architecture this, architecture that, solution, architect, blah, 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 and so on. That's because people are dealing with very huge code base, and they try to get it under control, and they try to use architecture to achieve that. I guess that most of us get a brief understanding, at least a brief understanding of what architecture is about, more or less. But if there was a non-technical person who would ask you to define what is architecture, to explain it just in easy words, how would you describe this word? Think for a while and speak. Sorry? Way of doing things. Maybe some. To structure the code. Yes. So one idea is how the application gets structured. So is it like grouping similar stuff into similar places, like grouping files in directories? Like, this is one possible attempt, right? It's okay, but it doesn't cover the whole big picture, right? Another idea is to think about the tools, because each tool has some kind of patterns used underneath, and it has some consequences of the pros and cons. So this is also okay, but it also doesn't cover everything. Like, there are many definitions for architecture. The one that I like the most is all the design decisions you have to make before you actually implement something, right? So it's all the technical questions you need to answer. It's all the why, how, and what you need to do and answer this. So an example design decision you have to make is when you want to do a system remake. You want to create a new version of an existing application, right? So how do we deal with that? The first thing we might do is try to measure how long does it take to re-implement everything. This is okay to do this, to think this way, and this is okay to do this actually when we deal with small applications. But in our case, we have 3 up to 400 modules, and each module is like a few months of work of a whole team, so it would take years to re-implement everything. So we need to think of a way to split it into smaller chunks, right? So one possible approach is to pick up the most used features and to create a greenfield, a new project which uses the top trendy tools, right? And to make the legacy just as a fallback. If the user uses one of these most popular features, it goes into the new application. If it uses the less used features, it falls back to the other one. This is still one of the solutions. The good thing is that we have entire flexibility in the new application, but we need to share some kind of sessions, share some data between them, right? If the user clicks something in the old one, it needs to update, in the new one, it needs to update the old one, and the other way around as well, right? So we introduce some overhead. Additionally, if we want to link the applications between each other. So this is one solution. Another solution is that we try to develop new features and inject them into the existing infrastructure. In old legacy systems, we've got all this, server-side rendering like Java, .NET, PHP, Python, whatever, right? So we would just replace the view layer with Angular components here. The drawback is that we don't get a single-page application because a given page gets rendered on the server, and it is the browser who will actually execute within this page the Angular component. But we get a little bit more flexibility in terms of how much we can do, and we don't need to deal with this overhead to synchronize the applications. Again, we chose the last approach, but it doesn't mean that it's the right one and the other ones are the wrong ones. It depends on your application, but it's very important not to pick the first decision that comes into your mind, right? Try to think about many decisions, compare them, and try to pick the best that you can see at the moment. So, in old school applications, we have many layers of nested backend logic, right? And at the very top, we've got the view layer. So we've got, in our case, it's Java server pages, JSP, but it could be, ASP.NET files, PHP templates, whatever. So basically, we grabbed all these files for a given module, removed them, and put just an Angular component. So this is just one liner that is rendered on the server. This HTML goes to the browser, and then the browser executes Angular and does all the client-side thing. So it's flexible because we can just pick one module and replace it, right? And we don't have to do anything more because this goes through this whole infrastructure, right? So we can pick one module, then another module, and one by one, right, so on. So if we gain this flexibility. If we have more time, then we can replace more modules. If we don't, then we just do a little less, right? So again, this is one possible approach, but it's good to think about more. Another design decision we have to make if we think in terms of both Angular 1 and 2 is actually what is a directive in our system? What does it represent, right? So originally, a directive is just a piece of reusable logic. If we talk about attribute directives, we get reusable behavior, right? Something we can attach to, and this thing just gets this behavior. And if we talk about element directives, we are talking about a visual component that we can display, we can interact with it, we can do something on it, right? But it's still pretty general and pretty abstract. And if we allow people just to do anything with it, that there are element directives and attribute directives, then you can assume that everybody will do it in a slightly different way, making the system inconsistent, right? That each piece will be done in a slightly different way. So we would try to provide some kind of guidelines, just like the previous speaker was talking about, but in terms of, let's say, more bigger picture. So one question to answer is, what is the relationship between the directives, right? The previous slide was just one component, but as you might guess, it's not just one very big component that has lots of, like, thousands of lines of code, but it's just split into smaller chunks. So we would, the question is, would we split it into sibling components or to parent and children, and each of the child would have its own children, and so on and so on. So what is the relationship between the components? Next question, what is the responsibility of a given component? We could assume that the parent component would shoot AJAX calls to fetch the data, right? But do the child components also shoot the AJAX to fetch the data? Or would the parent just pass the data to them, right? Or another thing, do the child components only display the data and pass a action via ng-click, ng-select, and so on to the parent to update it? Or do they also get some logic inside, right? Who holds the logic? Is it only the parent? Is it both parent and the children? Or maybe we separate something into the service, right? So in terms of each project, these answers might be completely different, but it's good just to think about it. How should this be? And finally, communication. So do we keep a shared state in a service, or do we keep the state inside the parent component, and the parent component might generate some functions, and it would pass the functions down to the children. So when a child component button is clicked, then ng-click just executes this function. It doesn't know what it's doing, it just clicks it, right? So these are completely different approaches we can choose. So we can see that software development is not only about coding, it's about making those design decisions and then about implementing them, right? So the question that arises now is, when do we make a certain design decision? It's very tempting to think about the first idea that might make sense and try to implement it immediately, right? Because if it works, why just bothering? Why thinking about it for longer? But we're missing two things here, two important things. One is that tomorrow we would have more knowledge about the system than we have today, which means that tomorrow, the decision we would make tomorrow would probably be a better decision than we are able to make today, right? This is one thing. Another thing is that the technologies are changing very, very fast, and especially they change fast in JavaScript. So basically, the best practices of today become anti-patterns of tomorrow. And you can imagine how many people who decided to use, let's say, require.js regret this decision now, right? Because each decision reduces your flexibility, right? So sometimes it's good to try to postpone the decision as late as possible, right? Always try to think, maybe I don't have to make a certain decision right now, maybe I can postpone it, or maybe I don't have to make the decision at all, right? So try not to pick all the tools immediately and narrow yourself down, because you lose this flexibility, right? Each decision reduces your flexibility. Also, if you want to revert a decision once made, it will cost you, right? The more time has passed since you made the decision, and the bigger the system is, the more it will cost, especially if this was a bad decision, right? So, if you are speaking about the tools and the decisions, how many of you know the JavaScript fatigue term? Hands up. Okay, there is only a few of you. So basically, let's say that we are starting a new project and we need to decide what is the templating engine. We need to decide what is the CSS preprocessor we use, what is the test assertion library and the test runner, and what is the module bundler we're going to use, and the task runners, the automation platform. Then we decide what is the framework, and on top of this framework, we need some kind of, let's say, higher level architecture. And finally, nowadays, nobody is writing in JavaScript. We have a bunch of alternative languages around, right? So as you can see, this becomes quite chaotic. There are many different combinations, and if we wanted to make the best decision possible, we would have to, compare all those combinations, and this would take a whole lifetime. So basically, this is JavaScript fatigue. This applies to new projects as well as updating existing projects with what is with the recent changes. And another thing is that when I go to meetups and conferences, often I see people comparing what they're doing like this. So it's just comparing the names only. The reason for this is that people tend to think about the tools only, right? I'm using Angular or I'm using React, right? But I think it's wrong. I think the right thing is to think about the problem you solve at the moment or you want to solve at the moment. Because this makes you think creative, in a creative way. You think about different ways to solve a problem, and then you try to pick up the right tool. If you think about the tool, then you narrow yourself down to the possibilities of the certain tool, right? This is a big difference. So let's get back to enterprise for a while. An enterprise company is a very specific, let's say, environment. There are many strange issues that exist there, and they don't exist in normal world. So let's talk about this. Can you see what this guy in this picture is doing? Yeah, he's painting the grass green. And in Polish, there is a phrase, to paint the grass green, as most of you know. It means to perform some activity that provides absolutely no value, right? And this is what people do in enterprise, most of people. And this is absolutely normal, this is acceptable, nobody gets fired, right? Yeah, believe me. So, you can do this individually, or you can do that in teams, right? It depends on one factor, whether your company prefers individual experts or Scrum teams. So, anyway, the problems that we deal with in enterprise companies is, first of all, budget-driven development. We are limited on time, both on time and the money we can spend on a project. Then we work in distributed teams. So we're not working in the same office, the same city, same country, but also different continents and hence different time zones. If we're working on the same place, on the same piece of code in different time zones, it gets pretty difficult to do. We're painting the grass green all over the world. So another feature, another thing is that backends become unavailable quite often. There is no one backend in enterprise. There are many small pieces, right, that make up the big backend thing. So if there is just one feature that goes down, it can happen that the whole thing goes down, like login service. If there is an environment and the login service goes down, then nobody can log in, right? And this is pretty difficult because if a front-end developer wants to shoot a request to the backend, then there is no response, there is a timeout error, and there is basically nothing we can do about it, right? Another thing is that backend can force a change on a front-end, right? So if there is a backend developer that changes the API response JSON structure, then our frontend will break, right? So what we can do is either adapt immediately or just do nothing, and the application is down all the time, right? But this is pretty unfair, but that's how life looks like. And finally, the backend needs to be implemented prior to frontend. If we're starting a new module and both the backend and the frontend is doing this module from scratch, then if frontend needs to access some data in the backend needs to be done prior, right? First, it has to talk to something, and this will take weeks until something is finished. So basically, we've got some backend-related issues here that we want to fix. And Angular 1 comes with a beautiful solution to this, an amazing feature called HTTP Backend Service. And what HTTP Backend allows us to do is that we define a list of functions like this when we define that when there is a call to, let's say, get/user/13, then there would be a function for this that will execute another function, right, to handle this call. So basically, we can mock a GET request, we can mock a POST request, put, delete. Not only we can mock just the data that backend is returning for us, we can mock the whole backend, let's say, behavior, right? So we shoot a GET, we get 5 elements in response, then we shoot a POST, we create a new element. Then when we shoot a GET again, we get 6, right? And everything is just put inside the browser. All this data resides in the scope of a function. It's just pure JavaScript, but it's really flexible. It allows us to become completely independent on backend issues. So this approach is called backendless development or front-end first design, whatever the name. But basically, when we start to do a module, some front-end guys and some backend guys meet. They discuss how the REST API should look like. We discuss what is the contract. We agree on this contract. And then we can split. The backend guys are doing their stuff to adapt to this contract, and the frontend guys mock the backend so that we can do all our stuff independently, completely. Roughly, it takes us 90% of the overall time to provide the whole functionality, and then we just take 10% to do the front and backend synchronization, because the world is never perfect and there is always some small things to fix, right? But we are completely independent. And HTTP backend service is a beautiful feature, it's just really amazing, but it's not good because it provides some features for us. It's really good because it solves a problem that we have in our application. The problem is the important thing, not the tool. So another problem that we have, the last one I'm going to discuss, is performance. How many of you are aware of performance problems in Angular 1? And how many of you could explain how it works? Why is it a problem? Okay, so there are few people. Basically, the killer feature of Angular 1 is the two-way data binding. There was some time ago that everybody was like, wow, two-way data binding, right? And now it's not like this anymore. Basically, when we use an ng model directive, we are doing a synchronization between the view and the model, right? And when we do interpolation, so just displaying a variable, we are doing a synchronization the other way around, like from the model to the view. So each of these is creating a watcher in terms of a scope, of a directive, of a controller, of a component, whatever. It creates a watcher. So basically, for each turn of the digest cycle, this watcher will have to be executed. So let's say I'm making a click here. I'm just clicking a button. This button click, or anything that would go on in this application, will signal the root scope to execute all the watchers it has registered. And if there is any change of any of the watchers, apply the callback function of this watcher. And then tell your children to do the same. So it will tell this child to do the same, and it will tell its children to do the same all over again, right? So if it happens, let's say that this guy has a watcher that will update something that this guy is listening on. Maybe it will, maybe it won't. We don't know because we don't define such things in Angular as we did in jQuery or Backbone, whatever. Maybe there will be such change. So, for this reason, we need to do another turn again of this whole digest cycle, right? And if the second turn of this digest cycle will change something that another one is listening on, then we need to do this cycle again, right? So, this gets pretty tricky if it comes to performance, right? Because just one click can trigger lots of, calculations around, right? So this is a problem we have. One of the solutions is to use the double semicolon syntax, which was introduced in Angular 1.3, which displays the data once, but it doesn't create a watcher. So if the myvar variable changes, there would be no synchronization after this time. But it can happen that you want to watch on the changes all the time. And the solution to this problem is just not to do two-way data binding. It's to use one-way data flow, which is a very good reason to migrate to Angular 2. So the future is, we want to see it bright, right? Remake of a big system is a very big investment for a company. We have spent 2 years to do the migration, and we achieved to migrate 10% of the whole application. And the fact that Angular 2 was released made our application legacy already, right? So we want to migrate to Angular 2 for a couple of reasons. One of them is performance. But it's not easy to convince the business, but that's another story. Anyway, if there is just one thing I would like you to remember after this presentation is don't focus on the tools you use, focus on the problem you want to solve. Because if you think about the problem, then you will more likely think in a creative way, right? Try to find different solutions to a problem and then to adapt the right tool. But if you think the other way around, think about the tool, then you get limited down to the capabilities of this tool. And if all you have is a single hammer, that everything looks like a nail from now on, right? So that's all I've got for you. Thank you very much.